Round 2.
Oh, yeah.
School is back in session with Dr. Rob.
We burnt those memory cards.
I'm telling you, that's right. That's right. A lot of footage to draw. Okay, so to wrap on the... I got to pull my notes from the last one. We went through... Really, we started out with three stages of farmer's mindset in a full crop year. Beginning of the year is we're at best crop of our life. Halfway through is, we'll see. Maybe some of it, maybe not. And then the end of it is either screw it.
Yeah, time to tune up the snowmobile.
Yeah, that's right. Tune up the snowmobile. Or let's push this thing. Because it might be one of the best crops of our life, or have the potential to be a great one. And then we went through in-furrow, the beginning of the seed stage, most impactful portion. And then after that is combating issues with soil fertility by foliar. And then we went to post-emerge herbicide application and how to mitigate stress at those times. And then... now we're at the last leg of the race.
The mighty tassel.
That's right. And so last leg of the race, we're really at this fork in the road. We've got, and nature decides this one for us. It's one of the decisions on the farm we don't have to make is this one whether we're going to have a good year or a bad year, because that is all weather related. So let's say this is not looking like a good year. And I mean, if it's a total failure, it's a total failure, period.
Yeah, and then you have to know when to pull the plug.
Yes, and there is not, the only application that's going to save you is rain. And even at some point, you get to a certain point. I've been there once where even rain didn't help because we were too far gone. But I hope and pray no one is in that. I know people will be, and that's, it sucks, man. It sucks to be a farmer in there. We've all been there.
Yeah, because you've already invested so much.
If
I'm going to have a failure, I'd rather it in the beginning. Then I don't at least invest all that money.
Watching a crop die is so
Worst.
tough. It is torture. It is torture to a farmer. Anyway, and so let's go down. But say the crop isn't completely dead. But let's say, hey, is there anything we can do, or how in plant function, that we can mitigate the dramatic loss? Maybe we can slow the loss. Maybe we can recoup a little bit. Can you talk about let's say, high stress crops? We talked about stress product. Can we talk about just that environment? What's going on with plants? And how can we understand the plant? Because we know we can make a better application based on our knowledge of how a plant works. Can you talk about how plants function in a stress environment? And then where are some areas that we can impact instead of throw it all out there and hope something sticks? How can we be very intentional with what we do if we do decide to do something?
Yeah, no, absolutely. And I think... I guess the simple answer to that is source to sink relationship. So it's not just post reproduction that source to sink is important. It's very important post reproduction, but all of plant growth is a transfer of the sugars from where they're made to where they're going, or maybe from a seed where it's stored to where it's going. So all we're doing as agronomists is managing this source to sink relationship. So we have to talk about the sources and the sinks of stress or of good weather, and where these carbon pieces should be going. And we kind of started or briefly introduced it last time about sources or ethylene, and that maybe nitrogen isn't the most limiting nutrient. So if I was given an exam to a group of students, I would ask them to write down the 17 essential plant nutrients. And the three most often that are going to be forgotten is C, H, and O, carbon, hydrogen, and oxygen. Because it's not in our fertilizers, it's not in our tanks, it's not in our mines. So if we're under a lot of stress, some of the carbon that we take in from the air to make plant with will become carbon gas called stress ethylene. So in this case, the source might be the leaves, or it could actually be the grains, the pods, the reproductive parts that we are going to try to harvest, that'll become the source. And now the sink is going to become the communication or the stress ethylene, so that plants, they work in a community, in an ecosystem, it might be called. So now it's my responsibility to tell you that we're under stress. So now my sink becomes stress ethylene. So we'll turn some of the starch or oil that we built in either the grain or in the pod, and we will turn this into carbon gas, and we'll actually cannibalize our own pods in releasing this signal so that my neighbors can know to start to defend themselves. So under really, well, assuming we can salvage the crop,
Sure.
under these conditions, and we know it's stressful, it's hot, dry, things like that, we want to minimize that loss of stress ethylene. And we'll do that by using antioxidants to stop the bubbling in the cell that's going on under stress.
That's the
So that's the phosphorus
peroxide?
Maybe we should talk about, that's a very complicated topic, and we talked about it in about 5 minutes.
Okay, Josh. I was going to say, it's Josh Pretzer level here. Josh Pretzer level here.
Your plant harvests the energy from the sun, and it takes in CO2 from the air, and it takes in water, most likely, hopefully from the root system, and it mixes these things into whatever they need to be. If you took the weight of an actual plant and then ashed it, burnt it, and then looked at the different minerals, even nitrogen is only in that plant in very, very small amounts. The vast majority of that plant is carbon, hydrogen, and oxygen. So this all happens through literally a miracle of life, and it's photosynthesis. And this happens in the chloroplast inside the cell. The chloroplast, it's a fatty membrane. Take it down to Josh level. This morning, we had toast, over there at the IHOP. And when we put that butter on the hot bread coming out of the kitchen, it melted.
Sure.
Now, I wasn't in the kitchen at the IHOP. They don't let me back there. But when they took that out of the fridge this morning to serve us, what was it?
Hard butter.
It was very hard butter. If I tried to spread that on my bread, it would have ripped my bread apart.
Right.
Now, once my bread was hot and toasted, when I took that butter and spread it on my bread, it just melted and went away. So
that's why they tell you to melt butter when you're baking cookies.
Yeah,
and
exactly.
not throw the stick in there.
Get it in there. We're ready to go.
That's right.
So the same thing is happening in the chloroplast of the cell. The chlorophyll contains the chloroplast. The chloroplast harvests the solar energy and turn it into plant. It turns it into yield. It turns it into sugar. Turns it into everything that plant needs. So when the plant's under stress, for all extensive purposes here, that butter is not the right consistency. And we've all been in the sun. We've all know what the sun can do with us. Some of us are sunburned right now from planting, and we turn red. So under optimum conditions, that molecule I'm talking about, it's harvesting the energy, and it's putting it down these transport chains. It's taking it away, and it's not causing that sunburn.
Sure.
Now, if that organelle, that butter, is a little too hard or a little too soft because of some environmental factor or farmer-induced factor like herbicide, now it's not efficiently harvesting all that extra energy. So energy bounces off in the form of light energy, electrons and photons, and it hits what are plants made of. If there's wet weights and dry weights, plants are predominant about 90% water in cells. Even in a dry year, plants have very high levels of water.
Sure.
And
you take a pigweed plant, you cut it off in a drought, and you just lay it on the ground. You come back 2 days later, it is a fraction of what it once was.
Absolutely.
The plant material didn't leave. The moisture just left.
Absolutely.
And you have this little just shriveled thing when before it was this big looming bush.
Absolutely.
Yeah.
So even in a bad year, the plants are full of water. Well, when these chlorophyll molecules aren't functioning efficiently, that extra energy is hitting the water and it's binding oxygens onto the water and it's creating H2O2. That's hydrogen peroxide. And we know hydrogen peroxide very well. And
Yes.
you have it in a brown bottle at the pharmacy. And now I see the fancy ones with the sprayers on them.
Oh, yeah. Right.
And you put this on your cut, your wound, and it bubbles, it foams up. The same exact thing happens inside a cell that's under stress. So now this extra energy is going into the water inside the cell and causing bubbling. The plant feels the bubbling and it starts to take its carbon that used to be in the grain or used to be in the pod or used to be in the leaf, and it turns it into stress ethylene. Ethylene is just carbon gas. And this ethylene now floats out my stomates and it goes to my neighboring plant and tells the plant, wow, we're under stress. It's time to ripen. It's trying to die. It's time to set seed. Why do you never have to plant your pigweed? It's there, right? It's in the soil seed bank.
Yeah.
It's not like you and I, how do we preserve ourselves? We run away, we save our own lives.
Sure.
For a plant to preserve itself, it just flowers, it makes seeds, and it dies. And
Right.
it puts it in the ground, and that pigweed is going to be there forever.
Yeah.
So your corn, your bean, it's doing the same thing. When it senses that ethylene, the ripening hormone, it tells
Hurry
it
up.
to hurry up, set seed, and die. It's not about yield.
Sure.
It's about having a viable seed.
That's why on dry years, stressful years, harvest is always sooner.
Absolutely.
The plant just shut down faster.
That's the stress
We have to-
ethylene.
we have to produce children. We're not going to produce as many, but here's what we can finish off, so away we go.
That's how it survives forever. That's why you have
That's
a weed
Dr.
seed
Rob
bank.
and Josh Level.
Yeah.
Die faster.
Yeah, it just makes it die faster.
Yeah.
And that signal is literally coming from the starch that's stored in your grain.
All right, guys, so we've got a website, singularagronomics.com. Check out the link in the description below. And we got all kinds of stuff on there.
Oh, yes.
We've got product, we've got merch,
Merch.
we've got newsletters, blogs, videos, links taking you places. The nerds they're always adding stuff to that page. So anyway, check it out. It's a great resource. We're working really diligently on consistently keeping that thing up to date.
Well, yeah, and I would say, you said the link below. If you can't find that, just Google Singular Agronomics. It'll get you in the right direction.
Yeah, you'll find us. So appreciate you guys. Got it.
So that's what you've been calling phantom yield loss. That's ethylene. It's not moisture. It's ethylene floating away. And it
Interesting.
costs the plant energy to harvest that CO2 and turn it into grain.
It was such on the social media platforms, dude. It was a war on whether phantom yield loss was a real thing or not. There were people dying on the hill that it wasn't a real thing. There were guys dying on the hill that it was. And it's like, okay. I don't know. I mean, maybe it was just a fad and people were just hyped up about it, and maybe that's what it was. But it's ridiculous. I shouldn't say ridiculous. Maybe it's a good argument to have, brought up some good points. But, people are like, it's reduced moisture. Well, it's reduced ethylene.
No, because you're selling your crop at a very standardized moisture level.
Yes.
It's not the moisture, it's the carbon that you lost.
Yeah.
And that's in the form of ethylene. It
Gotcha.
could also be, another great example is with soybeans. Now, believe it or not, down south, we're still growing some determinate bean varieties that they just kind of grow, set seed, and die. More like a corn.
Sure.
But up here, we're growing I haven't seen a determinate soybean up here in, I think, my entire career.
Sure.
Here, they're all indeterminate. So they want to grow, they'll grow forever until a frost kills it. So we have these really hot, dry years where the beans are just sitting there, they're not doing anything. And then all of a sudden in September, you kind of get this light rain and it cools off, you get that cold snap, and all of the beans, they grow a new trifoliate.
Yeah.
That is also at the expense of your pod. One of the things I unfortunately had to learn in school. We used to measure this, right? And a Sharpie marker, you can write on the pods, and it lasts. So go out there, in August when you have a nice 3 or 4, hopefully 4, right?
4.
4 pods in there, and it's plump. Find yourself some good ones, and just write on it with your Sharpie marker, and then go there after that $1 million rain.
Right.
And you go out there that day, and you see the new trifoliate, and look at that pod that you marked with that stupid Sharpie. I spent so much time in a field, you could tell. And go look at it, and it's flat. So the plant, it's a two-way street up until the very end of its life cycle. So if suddenly the conditions change, there was no stress, now, or the stress is gone, now the plant says, hey, I'm going to grow a new leaf. Now, we're lucky corn can't do this.
Yes, we are.
A new trifoliate comes out. That's also phantom yield loss. But in that case, it wasn't ethylene that flew away. It was the plant remobilizing the source to sink and taking that carbon out of the bean and turning it into a new trifoliate to make a new flower.
Is that because the plant thinks I can make a new improved, quote, baby?
Exactly. A new flower, new baby. Let's make more babies.
Okay.
And it's all because of hormone balance. There's 5 key hormones in the plant, and these hormones are predominantly made in the roots, and the hormones are there to sense the environment and signal the plant what to do. So it doesn't have eyes to see the thunderstorm.
Sure.
But it can sense these environmental triggers. Maybe it's moist ground, high temperatures, low temperatures, whatever you might want to be. And then it changes its hormone profile internally, mostly through the roots. That's why they say the roots are the brains of the plant. It's because those 4 of the 5 hormones are made in the roots and then transported out throughout the plant. And it's the balance of those 5 hormones that are the decision-making process of the corn and bean crop. So you've just changed the source-to-sink relationship because you changed the environment. The plant's responding. Now it's got more gibberellins, more cytokinins, and that tells it, make leaves, make leaves.
So what do we do to reduce that lost bean, that lost pod, or is tip back in the same category in corn?
Tip back is heat stress. So tip back is cytokinin and cytokinin oxidase. So we could talk about them, but those are hormone things.
Okay.
I like tip back better. I mean, it's earlier in the season, and then the what do you call it? The new trifoliate's typically later, so we'll go in chronological order.
Sure.
You got to go back to evolution now. So the plant's growing out in some jungle or wherever it was harvested. Corn I still haven't found it. Corn came from Mexico, and I live near Mexico. I've been on trips in Mexico. I want to find the wild weed corn. Teosinte, where I was growing. I still haven't found it.
Okay.
Anyway, so think of this plant growing out in some hot Sonoran desert. And if it's too hot, the plant, think of your hormone. I don't know how far you want to go into hormones, probably a whole nother talk.
I should say, yeah.
But certain hormones promote different things. Cytokinins, they promote leaves and shoots. Auxins, they promote roots, strong roots, fat flowers, big stems, and things like that. They're more the female, where your cytokinin and your gibberellic acid, those are more the males.
Got it.
So, and there's a balance. Corn's a really cool crop because of the brace root. And so the balance where the roots and the shoots meet, your cytokinin levels coming from the roots are going to match the auxin levels coming from the shoots. And so when they balance each other out, you get a net zero. That's the soil line. So depending on the environmental conditions, the corn plant in particular, you might see a brace root. That's where your cytokinins and your auxins equal 0. And it just so happens to be out of the ground. That's not necessarily a good trait, to have brace roots.
Right.
So anyway, but if you think of evolution and you think of heat, what's the plant doing? So if I'm a plant, I'm in the middle of nowhere, I have all of these signals coming in through my hormones, and if it's really hot air temperature, what's the best thing for me to do? It's to keep my carbohydrates underground. So if I'm underground, it's cooler, it's moister, it's a better environment for my CHOs, my carbohydrates. So if it's too hot from heat stress, the plant will eat its own cytokinin. So that'll keep it promoting growth underground and inhibiting growth above ground where it's really hot. So when you have pollination and when you have the
That's why you get shorter corn on drier years.
Absolutely.
Okay.
That's
shorter
a cytokinin.
plants, less material.
The plant has an enzyme called cytokinin oxidase.
Okay.
And it eats the cytokinin like a Pac-Man.
Uh-huh.
And that Pac-Man makes more auxin in the plant than cytokinin. And the more auxin forces more of the energy underground, and it protects the plant from heat stress.
Whoa.
Really cool, right?
So what can we do?
We spray cytokinin on the plant.
Okay.
Right during tassel.
In form of kelp.
So different types of cytokinin, or different types of kelp have different hormone profiles.
Yes.
So yes.
So we're gonna do YouTube videos on the different ones.
Yes.
And what basically, the full dive of which one do we use and when, and then you guys can reach out to us if you're interested in those.
Yeah, absolutely.
And that's so it's kind of bringing this full circle is the introduction, the education, and then let the farmer decide what he wants to do and what direction with the information he's given.
Yeah, so you spray Kynotin on that plant right at the heat timing, and you will have no tip back.
Okay. Boy, that sounds great.
Oh, yeah. Now get back into another one with the bean.
Would you pair that with the stress?
The stress mix is going to the cytokinin heat stress is very, very specific. Okay. So in corn, yes, it would totally help to mix that with the stress.
Okay.
Now, if we're looking at general stress and losing ethylene, then that's the crop stress mix, and you don't necessarily need to pair that with cytokinin.
Got it. Okay. We'll cover that more in the videos. But, okay, so good year.
Well,
how do we push it? What do we want to?
Gotcha.
So we have a plant that's in stress. Now we have a plant that has had that rain, but had a lot of those rains, and it's cruising. It's cruising.
Yeah.
How are we going to see above this in the combine cab?
Okay. Well, you were just talking about your sons.
Yeah.
And when I don't know, you can't really tell your sons. Well, maybe you can. Maybe your sons are really good, but I don't know how young they are. But I have a feeling that you can't tell them when it's time to eat. Maybe you have to feed them when they start screaming. Is that?
Say you tell them, you can be like, hey, Mom said get to the table. And it's a yes, ma'am, or yes, ma'am.
So the corn plant, right, or the bean, the babies are, and they really are the babies. It's the next generation. So that little seed that's in the pod, or that grain, multiple grains on the corn ear, that is a baby. There's just 1,000 of them potentially on an ear, and 4 of them potentially in a pod. So these babies, they're going to eat. Their mom is going to feed the babies that are screaming the loudest. The babies that are hungry, they're going to cry. So what we want to do on corn or bean or wheat or anything is make the babies cry louder, because the screaming kid gets the most food, the most photosynthate. The most attention, absolutely. So
interesting.
We want to increase the source to sink relationship, create a bigger delta between the leaf
channeling nutrients.
To channel the nutrients in.
Okay.
So we like to use different micronutrients to do this.
Okay.
There's a whole hormone profile that also goes along with it, but the bulk of the work is done with boron and molybdenum.
Okay.
So boron.
Does it have to be paired with nitrogen?
So nitrogen is always helpful, because nitrogen is going to trick that plant into opening up. We use nitrogen to basically bore out the engine. And it especially on a good year, and it'll help your root tips flush. You'll have a lot of openings. You'll create more pressure, like literally water pressure. It's called turgor pressure. and you'll create more pressure in the plant so you can move more nutrients.
So like a melted urea run foliar.
Yeah, we like a melted urea foliar. We do
paired with boron and moly.
Yeah, we do a boron molybdenum product that we put 3% amino nitrogen into it.
Well, that's what I'm saying. If we're going to pair this with something,
yeah,
we pair it like with a foliar melted urea running the plane.
Yeah, and running through the plane, that's another good one. I think I love plane applications of urea.
Sure.
But honestly, we're getting there a little late. I wish you guys would do it a little earlier.
Really?
I would probably put it in at tassel. And maybe not in those silk
not
layers.
Not waiting a while.
Yeah, I tend to like the nitrogen because your nitrogen uptake that late in the season is rather slow. The key
you look
exponential.
at the chart, it does drop off.
And it's the chart. I mean, I love the chart,
Okay.
and I know the chart you're talking about. That's how I know. I love this paper. I've read it so many times, and it's probably one of the most groundbreaking papers that we've seen today.
Sure.
Fred Below and his guys out there in Illinois. But him and his students, they actually measured the patterns of all the different nutrient uptakes and timings. Now, but what's really most important about that chart, it's not the number, the level, it's the slope of the line.
Right.
So where that line is steep, you have rapid uptake. And where the line is shallow, you have slower uptake. You still have uptake.
Sure.
But it's a slower rate.
Gotcha.
So I always see a response from flying on urea, even if it's not melted. We'll fly on dry urea.
Sure.
Let's say if you got a wet year, you got pivot or something like that, and I always see a good response from that.
Okay.
But I think it's a little late. I would time it a little earlier.
So more tassel stage.
I'd probably hit tassel. Yeah,
Gotcha.
yeah.
Okay.
Kind of that fungicide
That
timing.
fungicide timing that a lot of guys are running. Okay.
But source to sink, right? To make the baby scream louder so that it gets fed more.
Okay. And then opening the channel for the moving nutrients to it.
Well, yeah, that's the nitrogen side.
Yes.
So, but the boron is what makes the baby scream.
Got it.
So grain screams when you put some boron on it. We talked a little bit about Pac-Man just a few minutes ago.
Yeah.
So all the hormones have an enzyme that eat them. Because what's hormone that can't be regulated? We know this one. It's a trick question.
Herbicide, right?
It's a herbicide.
Yeah.
Yeah, so think of your
Uncontrollable,
phenoxys, like 2,4-D, dicamba, things like that. Those are actually unregulated auxins. So it makes the plant grow itself to death if it can't manage that active ingredient. But the natural auxins always have a check. So yeah, auxin in plants like indole acetic acid, IAA. Then for every IAA, there's an IAA oxidase. And the oxidase is the enzyme that chews it up and keeps it in check. So when you apply boron, it kills that Pac-Man. And it at least depresses Pac-Man so it can't eat all the auxin. So what you get is a jump in auxin in the plant. Well, the plant's moving things source to sink to the screaming baby in semi-trucks. And in the back, in the trailer, that's your sugars. And driving the truck, that's an auxin, an IAA. So when you apply boron, you get that increase in auxin, and then it pulls more of these trucks into the babies. So you're able to get plumper, fatter grains, and you're able to keep those grains from denting.
When in soybeans?
Soybean is a whole, soybean's a great crop, right? But it's like the bastard
So
crop
corn
here.
at tassel.
Corn.
Or around there as much as you
Right
can.
around tassel's a good timing. You know,
Sure.
corn's very determinate.
When would you stop? When would be like, okay, this is too late. Doesn't make sense.
So go to bean. Bean, honestly, it's your season, and it can grow for a really long time.
Yes.
Here in the U.S., we're making an application at R2.
Okay.
Give or take is going to be a great time to do that to a bean.
Okay.
You get into Brazil and South America.
The same boron moly?
They'll do a boron moly right then at R2, but they'll also do a finishing application, and I've seen beans respond in that R5.
Okay.
I've seen recommendations into the R9. I debate that.
Sure.
You know, they're starting to really brown on me. Once the tissue's brown, you know, it's not moving anything anymore. But if you have green tissue on that plant, it's not too late.
Okay.
So you want to do a boron molybdenum application there, because the boron is going to help bring the trucks to the screaming baby, and molybdenum increases another plant hormone, and that's called abscisic acid. And that's the hormone that puts everything dormant, sends everything to sleep.
So it would slow that down.
So it brings the truck in, and it stops that new trifoliate.
I see.
It tells mom, hey, the season's really over. You got a lot of ABA in here. It's not time to grow a new leaf. It's
Finish
not
what you have.
Yeah, it tells it to finish. So
Got
that's your signal later in the season. And on beans, I've seen very late applications actually work.
Got it.
And then the nitrogen just makes the highway bigger, so you can move more trucks.
Got it. Okay. We I say taunted. We teased. Thank you. Teased everyone on the part 1 of taunted with pushing dent out of corn.
Yeah, dent is a physiological problem. This is not a genetic trait that we have to live with.
Because if you pull back an ear of corn, not every kernel is dented.
Yeah, no,
Generally
definitely
at
not.
the base of the ear, it's not dented,
Definitely
but at the
not.
top, it's very dented.
Absolutely.
Right.
That's because when the corn is a really good one, you can get a calendar from, I think it's Noah.
I was going to say Noah. I've got that on my notes.
Is that it? So I've actually downloaded it in Excel. It's a cool calendar. And you can do this with the weather reports and the high and low temperatures and basically kind of rank the stress at the timing. Mm-hmm. Corn is pollinating from the bottom up. So later in the season is really the tips. And the stress, not all the time, but the stress is usually later in the fertilization process, and not at the very beginning.
Sure.
So that's why you have such plump grains on the bottom, and the tips are usually backed off because you had higher levels of stress and more of a choice. Now the plant didn't have one sink, the grain, it had two sinks, the grain or the ethylene.
Mm.
So, and then I've heard it said so many times, I don't want to butcher it and further bring this on, but there was an old professor out of Iowa, and he used to say you could get, I think it was like 10 bushels if you just can increase the width of the corn grain by the thickness of a paper. Just this much.
Well, think how many there are.
Right?
You flex it that much.
I've never been able to find the actual reference, but I've heard different agronomists say different things. But we all agree that even the width of a paper on corn is a big deal in terms of yield.
Sure.
So, you want to do things with boron and molybdenum.
If it didn't take small amounts to sway the needle, they wouldn't nail us at the co-op for foreign material, Doc. And it doesn't take much foreign material to get penalized.
Really? Wow. I see. That's part of farming that I don't have to deal with.
Yeah. I mean, you have a little bit of dirty grain, they'll knock you at 2% or 1 or whatever. Well, you take 2% off of everything, a piece of paper becomes a very real concept then.
Absolutely.
Instead of, take away form, if you can push your kernel by fraction, think how many kernels run through your combine in a year.
Oh, billions.
Billions.
Yeah, absolutely.
Hopefully. I hope it's billions and trillions. But if you can affect every one of them by one, not even a partial fraction, that's a lot of opportunity.
Oh, yeah.
A lot of opportunity.
That's also where this whole uniformity comes from.
Yeah.
So like when all these record growers we were talking about in part 1, they're looking for uniformity, not necessarily, jumbo Franken ears on that plant.
Right, Franken.
It's because if we could have...
Notate that, Kirk.
If we can have every single plant producing a decent uniform yield or ear with very little tip back and very little dent over that acre, it's unreal. I mean, our planting densities here are very high.
Yeah.
And that adds up quick.
Sure. Man, we packed a lot in there, just like we want to do the kernels. Anything else you want to add on to? So that's the finishing stage. Anything right after harvest you think guys ought to think about? I guess we'll leave guys with that heart. we're in the combines, we're in the machines, we're thinking through this process of the applications we made, we didn't make. It's the report card time. When you're going across that field, based off your observation and working all over the world, what are some things that guys should keep in mind as they're going across? Things to look for, things to notice, things to think future, next year. Usually when you're in the combine, you're not thinking too hard about next year, but I think we all have that, or are guilty of, if I'd have done this, we could have maybe gotten an extra this. So when we're processing these thoughts and looking at next year, setting the stage for the next round?
Well, that's, I think, a good question. And I pick on guys a lot and say, I'm a trained field agronomist. Mm-hmm. We walk fields, we'll take four-wheelers out and do things like that, particularly when I was younger. And then I see a lot of my farmer friends, and man, they're not walking those fields enough. And they're really...
The drive-by look?
I mean, the 60-mile-an-hour weed.
That's right.
Yep, looks good.
Yep.
And it's... but we joke about it. But the combine is actually a great time to start looking at your fields. And you're going to have... And now, I have to say, I get to ride with guys sometimes when I'm showing up at the right time, and we're driving the field in the combine. The technology, and I'm not an equipment guy, the technology you guys got is absolutely amazing, what you can measure and look at. So one of the things I think I would do is maybe take some of those flags we were talking about earlier, the different colored metal flags, mm-hmm. and let's maybe have a blue and a red. And maybe we can flag some of those really hot spots, the real good places where the yield is jumping out of the books. And also, let's flag some of those thinner spots and some of the places where we've always had problems, or some of the places with big weed issues and things like that. Then, after the crop's all off the ground, and maybe you rested for a month because harvest is a lot of work.
Yes.
But then we have a lot of time to think, particularly before the ground's completely frozen, or even in the spring when it's kind of mm-hmm. still mucky and sticking to your boots. Then we can go there, and then this will hit another one of my sore spots with agriculture today. But then we can take meaningful samples. And so there's a lot of different tests going on now. I mean, we've always done soil tests, right?
Yeah.
And tissue tests aren't new. Now we're starting to see a lot of things like in this sap testing and different things across here and there. And then I'll get a lot of questions about this, These tests, all of them, including your soil test, are absolutely meaningless to me, the interpreter, or, me, the agronomist, me, the scientist. Mm. It doesn't matter what any one of those, they're snapshots in time. But let's say you just flagged, 20 hot spots on your 2,000 acres that you saw great results with that bean or that corn crop. And you just flagged me now 20 spots that were cold, and red flags. Now we can start looking at a bulk sample, or, take a few cores from the blues, take a few cores from the reds, and now we'll have two tests. Mm. And we'll look at this, and we can start looking at everything from your hybrid to your base saturation to the wind exposure to the biological life in those patches. And now what we've done is ground truthed your testing. And now I can start helping you when we read the differences. Because what's important to us on the farm is not this report, oh boy, we got 10 parts per million here.
Right.
It has nothing to do with that. This is 10 parts per million, this is 100 parts per million, this was bad, this was good. And now we can start to see what the problems and what the good things are, so we know how to address the farm next year. So,
building a trend line.
Yeah, we need to see the comparison. The comparison is what's important to us for the planning next year. Not necessarily, you should see my desk. I have piles of sap tests and tissue tests and soil tests, and it's you, Mr. Farmer, have to ground truth the test for us, Mr. Agronomist, to be able to tell you and make decisions from these tests.
Well, I encourage on the farmer side, instead of just handing it to you Dr. Rob, Josh Pretzer handing it paper to Dr. Rob and say, just tell me what to do. I know, right? It's like, try to have an approach of, will you teach me how I can do this better?
Those are fun for me.
Yeah, because, dude, that's the only way. What are you going to leave as a legacy? If you don't learn how to make an impact, you can't teach how to leave an impact.
Oh, yeah.
And so instead of, be a student of your soil, be a student of your crop, try to be, and it's easy. It's easy. It's so tempting to just tell me what to do. What do I spray and when do I spray it? What do I pull? When do I pull it? But that's why I wanted, what is it plant telling us? What is the dirt? What is all of this telling us?
Look at your plants.
Yeah. I mean, one of my things I coined was what's above ground is just a report card of what's going on below ground. And, because that's all we think about. We see the plant, we think, well, that plant looks pretty good. We so oftentimes just skip over the thought of what's below soil surface.
Oh, yeah.
And it's, I don't know.
And I think farmers sometimes get a bad rap for being non-technological in terms of industries.
Pitchfork bib overalls.
Yeah, exactly. And it's not anymore. It's not the case because so the sciences that computers are into now, they're very well known. Mm-hmm. We know electronics. We're learning like AI and some of these new things there, right? But what farmers are trying to accomplish and study are not known. So now we're getting into things like soil health or carbon farming. There's no science book. Like I can't go and take a course in this. We're still as scientists arguing over, is this good or is this bad? So you are now the cutting edge, the front line in the developing of a whole new subject matter.
Sure.
So it's
all these companies are using our data to learn.
You ain't kidding. That's I don't, and you
without ripping the Band-Aid off that sore subject.
Man, farming are they're so conservative. There's so many rights, and they're so self-sufficient. I love going into the communities because it's like, man, my friends in the city can't do any of this, and you guys could just live forever. And but yeah, it's funny how, oh man, you're the guinea pigs of data now.
Absolutely. Would you recommend farmer to be cautious with giving his data away?
You can
say skip on that question.
I'm an academic, right? So data is only I'm all about free data, so that we can all learn from the data and peer-reviewed articles. And what good is data if I keep it hidden?
Right.
But on the other hand, I wouldn't.
A farmer has more value than what he thinks.
A lot. The data's worth a lot of money to a company.
Sure.
Because then if you think about it from, a large company's perspective, they can use that data to now develop solutions to trademark to sell back to the farmers.
Right.
So I would, I don't know if I would sign long contracts. I think that's one of the things killing this carbon farming market. A lot of them want 10-year contracts. We have no idea, I don't know, kind of like this crypto, right? Like Bitcoin. Mm-hmm. We don't know what that's going to be worth in 10 years.
No.
So I think there's opportunities for both sides, the farmer and the data guy.
Absolutely.
To take advantage of each other right now. So let's just be cautious and go one step at a time.
Yeah, don't think that the information that you valued is valueless.
Oh, it's worth a fortune.
Yeah, and also just be careful, as we're being students and we're learning things, what works and doesn't work, just making sure that we are being, because the information that we're given has value to change a lot in the future.
Oh yeah.
And what we learn and how we learn. And so it's like many things. A lot of things can be, water. Too much water is a good thing. Too much water is a bad thing.
The number one growth regulator.
Water can be, and about anything can be used for good or evil.
Absolutely. One good example, I'd say, a lot of these carbon credits that people are able to sell for years, a lot of them are being measured in percent organic matter. So they'll give you X amount of money for each percent per acre that you're able to improve.
Sure.
And I can increase your organic matter. We can just do practices that I mean, I've actually seen organic matter increases in the 1% per year in that first couple of years, and that's completely unheard of.
Right.
And they'll pay you for this.
Sure.
There is no clear-cut evidence that increases in organic matter mean better soil. You know, a lot of anecdotal evidence is pointing in that direction, but I don't think we as scientists have actually proven that yet. So there's a lot of, it's a
lot of people jumping to conclusion.
It's a lot of gray area.
Yeah.
And don't get me wrong, I completely support increases in organic matter.
Right.
And it makes farming easier.
Right.
But
on a scientific level,
it's not there yet. They don't have that evidence yet.
Sure.
And they don't have the parameters to. So, like in that case, I think the farmer has the advantage on the guy buying the credit.
Sure. Because he knows more what makes an impact.
Yeah. And that's kind of where we're going, that you are on the front lines now. And what you're learning is new to science. It's really that cutting edge.
Fascinating. Well, we're probably out of time. Yeah, I'm getting the head nod over there. So we burned through another set of memory cards.
Nice.
But thank you very much.
I warned you.
I know. Oh, yeah, you're right. Yeah, we're going to burn more cards. Thank you. That's a lot to... I am looking forward... Johnny's here, but not in here. And he said, man, I'm looking forward to this because I'm going to get to hear this on the podcast as a listener for the first time. I'm looking forward because now, I mean, I have so many thoughts running through my brain because now I'm thinking, okay, I have more information. I can address this, and then I can address this. And what direction we go, having a game plan, because I like that. What if we turn off have a poorer year? And I can, instead of what do I do? It's like, this is what I'm going to trajectorize. I had made that word up towards. And if we have a good year, this is my plan this way.
Oh, and it's all good data
instead
for you.
Instead of just, what's it going to do? I don't know. And then,
no,
oh my
absolutely.
gosh.
And I have to be real careful when I visit your fields because like some of these things are once in a career opportunities. And I know it's the end of the world on the farm.
Right.
Like we're doing a big thing on pollen now.
Okay.
Pollen is kind of like the bastard. Nobody's studying pollen, and there's a lot to be learned there. We just had selenium. We were doing pecans down in Texas, and we had a selenium problem with some selenium toxicity. It came in as a contaminant on some MAP, and but we're talking about 1,000 acres of mature. I mean, the value in this, and it's going to be unfortunately a complete loss in terms of that acreage. It's not going to kill the trees.
Sure,
they're resilient, but and this is just the end of the world to that farm. But at the same time, I mean, the chances of seeing this ever in my career is very, very low.
Yeah.
So being able to go there and document it and learn from what happened. I mean, think of what we've just learned in terms of farming and application technology.
Pollen.
Oh, yeah, the pollen's pretty cool. And if you guys want to do it, I'm also looking for corn pollen. I am not really going to get into beans just yet, but my degree's in grass. So corn, wheat, oats, rye. I'm looking to study your pollen and look at the different treatments. So like that boron molybdenum, I want to see its effects on pollen. The calcium boron, I've seen that increase the size of the pollen and the viability. Pollination is everything.
And we never even talked about pollen before.
Man, we got
Why do we overlook it? If we didn't have pollen, we would have nothing.
We got a microbiologist too, and he's just looking at the pollen characteristics from the fertilizer treatments.
He says we got to end it.
Okay, no more pollen.
That's
I guess
right.
That's a whole nother
time. Anyway, thank you very much. Appreciate it.
Thank you.
Your time and dedication to agriculture. And check out the YouTube channel for more information on some of these stress mitigating things or yield enhancing opportunities. Take the information you've heard and learned, and we say all this in regards to trying to help farmers make good decisions using good information.
Yeah, and being transparent so they
instead
can make
of being
a good
told
decision.
what to do, this is an option. Here is when it makes sense, and let the farmer decide.
Oh, absolutely.
And so
Make
anyway,
informed decisions.
yeah, so Singular Agronomics YouTube channel for more of that. If you're interested in any of these, reach out to us at singularagronomics.com or social media platforms, etc. So great times. Thank you, appreciate it, and we'll catch you guys later.
It's great. Thank
See
you.
ya. Guys, thanks for watching the content so far. If you would like to see more, be sure to subscribe to our YouTube channel. We've got all the full-length podcasts, other video information, tutorials on there. Also on all the major podcast platforms and social media sites, Facebook, Instagram, TikTok, etc. So if you like this, go ahead and check more out on all those platforms.